Alright, so today you're going to look at inverse trig derivatives, and these guys are a little bit different because they don't necessarily follow a pattern that we've set up before, but there is a pattern for each one of these guys, and so you want to add this information to your trig card by your other derivative items, okay? And then keep them handy while you're working your math so that you can go back and reference them, okay? And so if you need to pause and do that, pause and do it. I'm going to go ahead and slide into the first example. So we've got this trig function here, inverse trig function, arc sine of x squared. Now the arc sine of x squared doesn't fall into one of our other regular categories, okay? But it does fall into the arc sine category. And you'll notice that for this trig guy right here, we've got a u right there. So u equals x squared. And if you'll notice, we've got a u right here. So I need to know what du dx is. And for this guy, it's not too horribly difficult. Now, we do need to understand that the absolute value of x squared has to be less than 1. Otherwise, this won't work. Okay, think about the largest value you can have for the sine is 1. So the largest value you can have for the arc cosine is 1. Okay, everything's got to be smaller than that. All right, now set your pattern up here. So we're going to take 1 over the square root of one minus u squared times du dx. And so simplify and clean that up, and what you end up with is 2x over the square root of 1 minus x to the fourth. And that's it. That's the derivative of the arc sine of x squared. Okay? That's all there is to it. So, how about you try one? One that's very similar. Like, say, this guy. And see what you get. Alright, now we have a particle moving along the x-axis, so that the position at any time is t is greater than or equal to 0, then x of t is equal to the arctan of the square root of t. What is the velocity when the particle is 16? Remember, key word here for us is velocity. What's the velocity of the particle when t equals 16? Well, we need to know the derivative, because that's where all the exciting things are going to happen. So take the derivative of the arctan. Actually, this would be take the derivative of the arctan of t to the 1/2 power. So if we're going to do this, what do? We follow our rule over here. So 1 over u squared. Here's u right here. So where's our u? Right there. You see it? So if u is equal to t to the 1/2 power, what is du dt? 1/2 t to the negative 1/2, or 1 over 2 square roots of t. So now just fill in the numbers here. So I'm going to have 1 over 1 plus u squared. Well, here's u squared times the derivative of u. Multiply those guys out. What do you get? Well, you get 1 over 1 plus t times 1 over 2 square roots of t. So here's what your derivative is. If I have a derivative, and I have a time t, can I find the velocity of the particle? Yes, I can. Just substitute 16 in here and substitute 16 in here. And when you get that done, you've got your velocity. So what have we got? We've got 1 over 2 square roots of 16 times 1 plus 16. So 1 over 8 times 17, which is 56 carry 5, 136 for the velocity. Do we have any units on this? No. So its velocity is 136 whatevers. Alright? So what if I gave you a problem like the arctan of x to the negative 1/2? And what's the speed of a particle when x is 4? Can you do that one? You try this one. See how it works out. Okay, here's an arc secant. And when you're solving an arc secant problem, again, you're looking for that u value inside. And I've got a u value here, just like I have a u value here. And then just follow and plug in the things that we need to plug in. So I'm going to let u equal 5x to the 4th. I need du dx, so I'm going to let du dx do its work here. And that's going to be 20x cubed. And then just substitute all the u's and the d derivatives in where they belong. So it's not a horribly painful deal. It's just a little bit different. So what is it going to look like? 1 over the absolute value of u, the absolute value of 5x to the 4th, times the square root of u squared minus 1 times the derivative. So what have we got? We've got 20x cubed over. Now here's the cool thing. Use your brain. This guy right here. We're taking a value of x and making it using it to the 4th power. So anytime that you take that value of x and go to the 4th power, you will get a positive number. And so what we can get out of that guy then is 5x to the 4th. So you have to pay attention on that, because there will be instances where we have to leave the absolute value signs in. Square out the inside here, 25x to the 8th minus 1. And then go ahead and reduce. You can reduce these guys. Okay, you can reduce these guys. So go ahead and do it. 20 divided by 5 is 4. And then the x cubed and x to the 4th leave us an x on the bottom. And there's your derivative. Not a horribly painful, awful thing to live through. But there is a little formula to use, and it's one that you can do. What about you try this guy? Find the derivative of the arcsecant of 3/2 x to the 1/2. Let's see what you come up with. Let's find the equation of a tangent line. Tangent line to the graph of y equals arc cotangent x when x is equal to 1. We have an x value, we have an equation, we're told to find a tangent line, and so what this means is we've got to find y prime. So what does y prime equal? Well, if we're just taking the derivative of the arc cotangent of x, this is not going to be a difficult one at all. If I let u equal x, then du dx is going to be 1. So substitute in the things you need to substitute. What you're going to end up with is 1 over, or negative 1 over, 1 plus x squared times 1. Negative 1 over 1 plus x squared. That's our derivative. That's pretty painless. Now what we need to do is look at when x is equal to negative 1. Okay, because we need to find the slope at that specific spot. So what do? Well, we say that negative 1 over 1 plus negative 1 squared, and determine what this is going to be, which it looks like it's going to be negative 1/2. So this is our slope. We've got an x value. How do I find my y value? I take my x value and put it in for my arc cotan. Well, how does this work? Remember that the arc cotan is the inverse of the cotangent. So if I say the arc cotangent of negative 1 is equal to, say, x, then the equivalent statement that we would be interested in is the cotangent of x equals negative 1. So we just need to figure out where this occurs, and that would be at what? What does x equal in this case? And look at your, you can look at your trig card, look at your unit circle, and where's the cotangent going to be equal to negative 1? And that should be at 3 pi over 4. So if I've got an x value, actually I want to change this bottom guy to y's, because that's really what we're interested in here. Y is what we need. So if I've got an x value and I have a y value and I have a slope, then I can write the equation of the line. That's all there is to it.